Okay, we're just going to have a look at the... Oh, don't know what's going on there. Just going to have a look at the free fall part, which looks short, but there is quite a bit to it, especially point three. So, yeah, this is an important part and hopefully will come up in your exam. So, describe what the acceleration free fall is on Earth when we ignore air resistance. That's number one. So, first of all, ignore air resistance. Well, air resistance is all around us, so you won't be able to relate to this very easily because ever since you were born, you've lived on planet Earth, hopefully, unless your physics teacher come from the planet, then you've been on planet Earth your whole time. And that means you've experienced air resistance. That is caused by the air molecules in the air, and they collide with you as you walk or you run, and that creates a force always acting the opposite direction to the direction you move. So let's say you're going that way, then air resistance, which I'll show you with the blue arrow, would act in the opposite direction and therefore would slow you down. So without air resistance, there is no backwards force against the motion. So let's say we drop let's do a classic feather and a bowling ball. There's no upwards force. So the only force acting on these two is their weight. Remember, weight is a force, and it's one of the equations you need to know. You calculate it by doing the mass times g, which is the gravitational field strength, which on Earth is 10. So what happens to both these objects? Well, it seems a bit counterintuitive. Most people say the heavier object, the bowling ball, would hit the ground first. But you'd be wrong, and you guys will now know the right answer. Have a look at this animation here. Both of them released, and they both hit the ground exactly the same time. And this is when all the air is removed. So there's no air resistance, and that's an important point. When there is no air resistance, all objects, regardless of their mass, accelerate at the same rate. And that rate is 10 meters per second squared. That is their acceleration, and it's the same as, or is equal to, g. Okay, just different units. So that's all you need to know at this level, is that with no air resistance, objects will accelerate at the same rate. So as long as they're released from the same point, doesn't matter how big or small they are, they'll all hit the ground at the same time. But this all changes when we add in air resistance. But first of all, let's talk about what is air resistance. Well, as we said, it's that action of when an object, you or a feather or a bowling ball, moves through air. Remember, air is made up of all these molecules. It collides with these, and they create a small force on this. So this force always acts in the opposite direction to the motion. So if this was falling down that way, so it's velocity downwards, then air resistance will be in the opposite direction. If you move that way, then air resistance would be in the opposite direction. I love this funky pen. Look at those colours. So that's what air resistance is. It always acts to oppose the motion or in the opposite direction, and it's caused by objects colliding with air molecules, and that slows them down. I mean, you've experienced it in a swimming pool. If you haven't, try running in a swimming pool next time you're in there, and you'll feel that force caused by all those water molecules colliding with your body as you try and run through it. Right, finally, we come on to the hardest one. Describe how the acceleration and speed of an object changes as it falls with air resistance. So now we're on planet Earth, where there is air resistance, and we're going to see how objects behave when they experience this air resistance force. Now, the best example for this is the skydive. And if by magic, there's a nice image of someone doing a skydive. Hopefully you'll get a chance to do that. New Zealand is very famous for its skydives, and while you're doing it, I want you to be thinking about the physics and this video here. Let's start with diagram 1. The moment you jump out of that plane or helicopter, don't know what's happened there, but that's fine. Let's do it over here. The moment you jump out of that plane or helicopter, there is only one force acting on you, and that's your weight. Okay, so that moment you jump out, you just have weight acting downwards. Remember from earlier or previous lessons, if there's only one force, we call this the resultant force, or leftover force, because there is no force upwards, your resultant force is that big. And this is going to cause you to accelerate downwards. Okay, so that means you're going to speed up downwards. You probably experienced that. I mean, if you just drop a pencil now off the desk, the only force acting on it is weight, and that's going to cause it to accelerate downwards. So that's what happens in step 1. Let's look at step 2 now, which is over here. So in step 2, what's happened is now you've sped up a bit. So initially, step 1, your velocity would have been 0. Your velocity now is probably a bit faster. Let's go 10 meters per second, your speed or velocity. So you're going a bit faster now. And as you've sped up, look what has happened. We now have air resistance. Because you sped up, you're hitting more air molecules per second, you now create more air resistance. So that means there is now an upwards force acting on this human. In this case, it's 350 newtons down and 350 newtons up. That's the air resistance, or drag, we can also call it that. And downwards is the weight. So what does this mean? Well, this means there is a leftover, remember, resultant force, and we remember calculating these hopefully during a lesson where you just take one from the other. So 833 minus 350 will give me 483. So that tells me that's the resultant or leftover force. In this case, it is acting down because the weight is bigger than the drag. So you are still going to be accelerating, but because the force is smaller, instead of in diagram A or number 1, where you just had 833 newtons acting down, you now only have 483 newtons acting down. So you're going to be accelerating, but at a lower rate. So you won't be accelerating quite so fast. You'll still be going faster, but not quite so fast. So far on a graph, if we do a speed time graph, and if you can't remember these, watch my other video, what's going to be happening is we're accelerating, so it's a line upwards, but the rate of acceleration is getting less. So the line's starting to flatten out like that. Right, let's see what happens in step 3. So in step 3 now, or diagram C, this one here, again, this person's going faster and faster, as we can see from this graph. The speed's increasing. We're going upwards that way. So that means that the air resistance is also going to get bigger because we're hitting more air molecules. I mean, if you want to think about it like this, the faster you go, the more air resistance there is. If you want to try it, stick your head out of the car. Well, let's do it on a bicycle. It's much safer. Don't do it on a car. That's dangerous. So when you're cycling slowly on a bicycle, you get a bit of air resistance. You can kind of feel a bit of wind against you. The faster you go, the more air resistance you experience. So now the resultant force here is going to be 133 newtons downwards. If you're not sure how I worked that out, I did the force of gravity, 833, minus the air resistance force, which is 700. So you can see how this force is getting smaller. Earlier on, it was 833 in the first video. Then it was 483 newtons downwards here. And now I've only got this small one, 133 newtons downwards. So what's going to happen? Well, that means the rate of acceleration is getting slower and slower. So this is starting to flatten out even more until we reach stage 4, where both the air resistance and the weight are equal. And this is a really important part. In fact, it's so important, I'm going to put it in a colourful pen. This is called terminal velocity. This is the fastest speed this person is going to reach in their skydive, because now there is no resultant force. The force is balanced. So this person, he or she, is going at a constant speed. There is no acceleration. Okay, it's quite easy to see this. If you drop your pencil off the table, you won't see it because it won't reach terminal velocity. But drop a piece of paper, you'll see pretty much straight away it reaches terminal velocity. The weight, force of gravity, balances the air resistance. So the two forces are balanced like that, and therefore the paper falls at a constant speed. We call this terminal velocity. What does it look like on my graph? Well, this is where it flattens out like this. Remember, we said constant speed. Watch my other video if you can't remember. Constant speed is a flat line on there. So what are the key points to learn? Well, you need to be able to describe what's going on. So the idea that the air resistance is increasing as that person goes faster, and eventually when we reach this flat part here, the air resistance is equal to the weight, and that's called terminal velocity. So you need to know that, and you need to know the shape of this graph. So remember, on a speed time graph, what's it going to look like if you free fall? Remember, this is free fall with air resistance. With air resistance. Flick back to the start of the video if you want to see the free learning objectives we were looking at in this video. This is with air resistance, not without. And it's going to look like this, slowly flattening out to reach terminal velocity. If there's no air resistance, what would happen is it would just keep going, accelerating like that, because there is no force acting upwards, so the object just keeps accelerating and never reaches terminal velocity. But with air resistance, we reach terminal velocity. There's some great videos on YouTube. If you just type in YouTube and go onto YouTube and search for terminal velocity, you will find lots of great videos explaining this in more detail. Perhaps add GCSE into your search on YouTube, and that will help explain it. You need to know this. It's on your Notes Quest. Hope that makes sense.